Hi, let's take a look at this question. We want the lamp to shine at its normal brightness as indicated in the question here. What does this mean? This means that we should aim for the voltage across the lamp here to be 4 volts, which is given to us in the question. Now, we can solve this using a few methods. Let's use the potential divider equation as the first method. Now, let's figure out the resistance of the parallel branch. The resistance of this parallel branch is made out of a resistor in parallel with a light bulb which has a resistance of 1 ohm. This should give us 0.667 ohm as the resistance of the parallel branch. Now with this, by using the potential divider equation, let the resistance of the unknown resistor, of the variable resistor, be just R, and we can then use the potential divider equation. A ratio of the resistance to the total resistance multiplied by the EMF across the whole circuit should get us the required 4 volts. And if you solve this, you should be able to get the answer of R equals to 1 ohm. Now we can also solve this using another method by using the current. So let's put this as method 2. If we know that the required voltage across the bulb is 4 volts, we will then also know that the voltage across the 2 ohm resistor is also 4 volts because the resistor and the light bulb is in parallel. So with this, we can calculate the current through the 2 ohm resistance, and this will be the voltage across the 2 ohm divided by the resistance of the 2 ohm. Then that will give us 4 divided by 2 to get 2 amperes. Similarly, we can do the same thing for the light bulb. So the voltage across the light bulb divided by the resistance of the light bulb. So we get 4 volts across a 1 ohm light bulb. This should give us 4 amperes. Now, at junction C, we know that the currents were recombined. Alright, so the current through the variable resistor will split into the current that is passing through the 2 ohm resistor plus the current that is passing through the light bulb. So with this, we know that the current passing through the variable resistor is 2 plus 4, that gives us 6 amperes. Now finally, the voltage across this variable resistor is the full 10 volts minus away the 4 volts, and this should give us 6 volts. The whole circuit here has 10 volts of EMF across it, and since the variable resistor is connected in series with the rest of the circuit, the shortfall will be 6 volts over here. So finally, by using Ohm's law, the resistance of the variable resistor can therefore be determined. This will be just the voltage across the variable resistor divided by the current through the variable resistor, and we should get 6 volts divided by 6 amperes, and this should get us 1 ohm, the same answer.